Hello everyone, my name is Nguyen, and I will be talking about my team's Innovation Day project. Our project is called Maventure VR, a virtual reality game that is based around the UTA campus. This project was worked on with 5 other members, and their names are Khang Tieu, Hunter Befort, Daniel Vo, Gabriel Vargas, and Moamel Mohammed. Our faculty instructors for this project are Dr. Carter Tiernan and Professor Benjamin Wagley. So what was the motivation behind Maventure VR? Initially, Dr. Tiernan had proposed the idea of a game to be used as a recruiting tool for incoming engineering students to UTA. The game would show off sites and buildings on campus that would consist of compelling gameplay to engage players while helping them learn about what UTA has to offer. On top of creating a fun and engaging game as a recruiting tool, this game would contribute to building energy sustainability for the future as well. But how does it do that? Let's start with some background about UTA. UTA is known as a commuter school, with over 90% of the students living off campus. According to the Shorthorn, UTA had set record-breaking enrollments in fall 2023 with around 41,000 students enrolling. Out of that 41,000, 4,809 of them were first-time college students. These first-time students are expected to attend the new Maverick orientation before being able to enroll in classes. However, some students choose to join an extended orientation known as Maventure Camp to engage more with UTA. Many of these incoming students come from all different cities all over the DFW area, many of which commute to Arlington. The average commuting time to UTA is about 30 minutes or so, and with such a large volume of incoming students making this drive every year, carbon emissions come from vehicle transport. With Maventure VR being software, incoming students can choose to telecommute to a more immersive virtual experience. Let's define some constraints for this project. While the game aims to simulate the entire campus, it's not feasible to model all 100 plus buildings on campus within a year, so our team focused solely on the engineering quad buildings. To streamline the development of this project, our team needed to figure out what systems Maventure VR needed. Since Maventure VR was going to be a multiplayer virtual reality game, we needed tools that could implement a client-server architecture along with virtual reality support. With that in mind, our team utilized MetaQuest 3 headsets, Blender, and Unity. Several Unity packages facilitated the development of the features we needed, such as OpenXR interaction for controller support, netcode for client synchronization, lobby to allow players to join one another, relay to facilitate connections between players with a relay server, and VVox to provide communication systems between players. Regarding the building models, they are created using Blender. To model each building, we would model floors and then stack them on top of each other. For floors, we would first make planes that match the evacuation map, and then scale them according to the dimensional drawings that we were provided. Once planes were created, they would be extruded upwards to create walls. With the walls created, windows would be inserted into them. Finally, extrusions and walls are made for all doors on that floor. For the engineering quad buildings, this process was repeated for 20 floors in total. While the models were being created, we scheduled 2 playtesting sessions with the members of the video game developers organization at UTA. This was done to ensure the quality of Maventure VR and so that we could gain feedback on the playing experience of the game. Here are the results for both of the hosted playing sessions. For each session, playtesters explored and played the game with one another for about 10 to 15 minutes in groups of 3 to 4 people. Afterwards, players were given a survey to give feedback on a Likert scale and any other suggestions that they may have wanted to add. Both playtesting sessions were 2 weeks apart, so for the second playtesting session, we made adjustments to the game based on the results and feedback provided from the first playtesting session. These playtesting sessions showed us Maventure VR had garnered interest and that the testers looked forward to future development. Players even gave additional feedback to make the game more engaging. Examples of provided feedback are audio such as music, voice lines, and sound effects, more campus information, more interaction in mini-games, and quizzes to test players. With this feedback, our team hopes to incorporate it to create a more engaging experience. In conclusion, Maventure VR has potential for future growth and to be an invaluable recruiting tool. While the game is currently only about the engineering quad and the engineering programs, it could easily be expanded to include other departments. Furthermore, simulations can be created in a safe virtual environment where you can explore different learning scenarios such as lab training. Our team would like to thank Dr. Tiernan, Professor Wagley, and the members of the Video Game Developers Organization for their assistance in this project. Thank you for watching this presentation.